All right, so this lesson today, it's really different than the lessons that we've been going over. We did that whole thing with the triangles and the points meeting in the middle of the triangles, and where I could have met on the outside of the triangle. But we did all those things, and now it just seems like this is almost completely different. In fact, we're not even going to talk about things that are equal to each other. We're going to talk about things that are not equal to each other. And so, what word do we use for things that are not equal to each other? An inequality. That's right. So if something is an inequality, then they are what? Not equal to each other. So 3, oops, let's try this again. Hopefully this works. There we go. 3, is that true? No. Well, in today's world, I don't know the way things are going. Um, people will say it's true, or people will say that I'm some kind of phobic or something if I say that 3 and 5 are the same thing. Who says 3 and 5 are the same thing, right? It's a construct. It's a human construct that people said that that's equal to each other. Well, these are not equal to each other. I will say definitively 100% that 3 does not equal 5. So we call this a what? An inequality. Now, if I said this, what would I call that? Oops, it's crazy looking. Let's try that again. All right. What is that? That's a what? Or an equality. It's an equality. Okay, so this is equal. This is not equal. This is an inequality. That's an inequality. All right, with that said, let's do this. Tell you what, I don't know what's going on with this tablet, but I think I have to write slower. It doesn't allow me to write very fast, or it messes up. I'll just do it like this. I'm going to put in parentheses that C has to be greater than 0. All right, let's take a look at this. This is kind of weird, but it's going to lead us up to what we're going to be doing. This is not like everything we're going to be doing. This just leads us up to what we're going to be doing. Hunter, you still with me? Do you have notes in front of you? You got nothing. You got nothing on your desk. All right, so if A equals B plus C. So let's give me an example. Give me a number, a relatively small number. Don't give me anything real crazy and big, but give me a relatively small number that I could put in for A, B, and C. 2, 3, and 7. Look, does A has to equal B plus C? So you got to give me 3 numbers that fit this little equation right here. Give me a number for A. 12. Too big? All right, you said 7 earlier. So 7 is equal to what? Give me a couple numbers. 3 and 4. I heard 3 and 4. Okay? It could be 5 and 2. It could be any of those. All right? As long as they equal each other, it could be anything like that. But it says C has to be what? Actually, B or C. C has to be what? Greater than 0, which means it can't be 0, right? And it can't be what else? A negative number, okay? So basically, it just means C has to be what? A positive number. Good. Okay. So let's see if this is true. This was our A, this was our B, and this is our C, all right? If this is true, do you agree that 7 equals 3 plus 4, right? What does this little statement right here say? That A, which is what? 7, has to be greater than what? 3. Does that make sense? Yeah. 7 definitely is bigger than 3, isn't it? You can do that with any numbers at all, as long as they fit these circumstances right here, okay, that C has to be a positive number. If you think about it, it just makes sense. These 2 numbers right here are parts that add up to be the big part, right? So they have to be 2 smaller parts. Would you agree? All right, so they got to be 2 smaller parts to make this one big part. So the big part has got to be bigger than either one of those other 2 parts. Does it make sense? All right, so if these 2 add up to be 7, the 7 has to be bigger than either one of these, the B or the C. We got it? Okay. Now, you're probably looking at this and thinking, well, of course, that's just common sense. And you're right, it is kind of common sense. But we're going to apply it to a triangle. All right, so let me draw a triangle. We've actually seen this kind of triangle before. But we're going to talk about it a little differently this time. All right. So there's a triangle. Let's call it A, B, and C. Just to make this easier, I'm going to call this angle 1 right here. Everybody see that? It's not 1 degree. It's just the name of the angle. I just named that angle angle 1 just to make it easy, so I don't have to like say CAD or something like that. Okay, I'll just say angle 1. Everybody go with that? All right. So with what we just said, in geometry, there's a thing that says this. Now, remember, we've talked about this before. Angle 1 equals what plus what in this situation right here? C plus B? Yeah, let's go B and C. Is that all right? So angle B plus what? Angle C. Yes? All right. So let's use what we just talked about, right? A equals B plus C. Then A's got to be greater than whatever it was, B or C or whatever it was. Okay. What about this? So this must mean that angle 1 has to be bigger than what? So if angle 1, or let's say it this way, if B plus C adds up to be angle 1, then angle 1 has to be bigger than what? Than angle A? No. Remember, these two add up. Okay? These two add up to be angle 1. Everybody see that? So if these two add up to be angle 1, then angle 1 has got to be greater than, that greater than symbol is starting to look like an angle, isn't it? But it's greater than angle what? Angle B or angle C, correct? All right. So I could write it like that. I could also write it like this, that angle 1 has got to be greater than what? Angle C. So it doesn't matter what these angles actually are. I will always know that angle 1 has got to be bigger than this angle and bigger than this angle as well, because these two have to add up to be angle 1, right? So whatever they add up to be has got to be bigger than the sum, right, of the parts. Does that make sense? Okay, and that's a theorem. They call this, I'm not going to write the theorem down. It's in the book if you want to look at it. But it's called the exterior angle inequality. So it's bad enough in geometry we're finding a whole bunch of stuff that's equal to each other. Now we got to find stuff that's not equal to each other, all right? So it's called the exterior angle inequality theorem. It's a mouthful. But it makes sense, doesn't it? An exterior angle. Angle 1 is what? An exterior angle. Okay, and then we made a little statement here that are inequalities. That's an inequality. That's an inequality. All right, so angle 1 has got to be greater than angle B, and angle 1 also has to be greater than angle C. Everybody good? So that's just talking about angles in one triangle, an external angle or an exterior angle, and the angles in a triangle. Let's take a look at this. Let me see what I want to do here. Two sides of a triangle are not congruent. Okay. Okay, here we go. This is a good one. It's all leading up to some things. That one right there, again, was kind of like common sense, I guess. But here's one that may not be completely common sense, but after you look at it, you're like, oh, okay, I could probably see that. I'll tell you what, let's make this a little bit shorter. Right there. I'm trying to make it so that the sides are not equal to each other. It's pretty good. So let's call this, which one do you think's the longer one? That one? Yeah. We'll just say, all right, this one's probably what? Bigger. And then this one's probably the smallest one. Okay? Let's call this angles ABC. And, oops, not what I wanted. I wanted this. Okay. I'm going to just scooch this over a little bit so I have some room to write. All right. Now take a look. We've got a triangle. I don't know any of the angles, but I do know the lengths of the sides. And I know that this is bigger than this, and this is bigger than this, okay? That's the biggest side. That's the next biggest, the middle one, okay, in length, and that's the smaller one. Sailor, what you saying? This is example, I don't think it's an example. This is just another theorem. This is called the greater angle theorem. And I'll show you why. And it pretty much makes sense that it's called the greater angle theorem. I'll show you why. Now, this theorem basically says this. If two sides of a triangle are not congruent, all right? So I've got I got all three sides not congruent, okay? So are two sides congruent? No. So it starts off saying if two sides of a triangle are not congruent, then the larger angle, the larger angle is opposite the longer side. So if I wanted to go through and list in order the biggest angle, the medium angle, and the smallest angle, I can do that without knowing any of the lengths or any of the measures of that angle. Okay, as long as I know the lengths of the three sides, I can tell you which one's the biggest angle, I can tell you which one's the medium one, and I can tell you which one's the smaller one. Okay, and this greater angle theorem says it's the angle that's opposite the largest side is the largest angle. So which one's the largest side? CB, right? 14. Everybody see that? So what angle is opposite side BC, or that 14 right there? Angle A. So which one's the biggest angle? Angle A. So angle A is the biggest angle. Let's go in order. What's the next biggest side? The 13, the AB, right? So what angle is opposite the medium? I'll call it the medium one, right, or the next biggest one. What angle is opposite this 13? Angle C. So guess what? Angle C is the middle one. And then, obviously, which one's the smaller one? I only got three angles. Angle B, right. So angle B, let's make that look like a better angle. Angle B is the smaller one. So this is the bigger one, that's the medium one, and this is the smallest one. This is how you could write it. You could say angle B is greater than angle C, and angle C is going to be what? Greater than angle B. All right, that's what the greater angle theorem says. So it says if you know the three sides, right, and if they're all different sides, different lengths, then you could be able to tell which angles are the biggest. So angle A, watch, is the biggest. I'll make that a real big arc. Angle C is the medium one. And then angle B is the littlest one, is the smallest one. Everybody got that? All right, that's sometimes very important to know. What about could we go the other way? Sure, we could go the other way. And they call this one, instead of the greater angle theorem, they call it the longer side theorem. Now, every geometry book could possibly change the name of these. Like if you learn out of another geometry book, they may not call it the greater angle theorem, but they probably call it something that makes sense as well, all right? So it just all depends, I believe, on the author of the book, on what they call some of these theorems. But there are some theorems that are just universal, like the Pythagorean theorem, right? Every book calls that the Pythagorean theorem and different things like that, okay? So let's go the other way without redrawing stuff just because of time. What if I knew, oops, let's do this. There we go. What if I didn't know the lengths of these sides? And let's say they put some angles in here. I'm not going to take some time and figure out because I've got to make sure they all add up to 180 and all that kind of stuff. But what if I said that this was the biggest angle, this was the medium angle, and this was the smallest angle? What could you say now about the opposite sides? So I'm given that the angles are not equal. I'm given what the inequality is for the angles, but now I want to figure out what side is my biggest one, which side's my middle one, which side's my smallest one. So what would you say? Which side is my biggest side? CB or BC. Why? Because it's opposite what? The biggest angle, okay? So BC would be bigger than what? I'll tell you what, I'm not going to put the symbol on. The length of BC would be greater than, what's the middle one then? What's the middle side? Remember, this is the biggest angle, this is the middle angle, that's the smallest angle. Which is the middle length? It's AB because it's opposite the middle angle. Everybody see that? So AB is opposite angle C, so AB has got to be the middle one. And what's the smallest one then? AC. How do you know it's AC? Because it's opposite the what? The smallest angle. All right? There you go. That's not too hard, is it? Right. You just look to see what the biggest side is. Whatever the biggest side is, the angle that's opposite that, that's the biggest angle every single time. You look for the smallest angle. If you want to find the smallest side of a triangle, and if you know the sides, the smallest side is going to be opposite the smallest angle. We good? All right. Let me just do one more thing real quick. Bell's about to ring, but I think we can whip through this really quick. This is just a little bit more specific to what we've been doing because we're dealing with what kind of a triangle here. It's a right triangle. I might have mentioned this before, but somebody tell me, we'll call it X, Y, and Z just to change it up a little bit. I didn't give you any lengths at all. All I told you was a right triangle. I told you which angle was the right angle. Which one is the longest side? XY, or the hypotenuse. Now, we did say that, though, didn't we? Remember before we said the hypotenuse is always the longest side? Well, why? Why is the hypotenuse the longest side? Because the 90-degree angle is always going to be the biggest angle, isn't it, on a right triangle? On a right triangle. So the side that's opposite the right angle has always got to be the biggest side. And so this is called the hypotenuse. Everybody with me on that? All right. And now it all depends on your lengths, which one is the middle angle and the smallest angle. All right, but that's kind of interesting. You ever hear this? Real quick, I'm almost done. We've kind of talked about this already. Oops, what am I doing? Why did I do that? Hold on. Just give me a sec. What's the shortest distance from a point to a line? What's the shortest distance? Is that the shortest distance? Is that the shortest distance? Perpendicular, that's right. Perpendicular is the shortest distance. Since we're talking about short sides, long sides, and all that, the perpendicular distance is always the shortest side. That's one of our theorems, okay? Both of those right there are one of our theorems. So, why don't you get started on it, okay? So 1 to 18, I'll let you finish it after your quiz tomorrow. But I am going to collect it tomorrow, okay? So if you think you need the whole time for the quiz, then get your homework finished tonight, okay? If you think you can do the quiz pretty quick and do the homework tomorrow in class, that's fine as well, but I am collecting it at the end of class. Can you scroll up a little bit? Yes.